DC, DCC, O gauge, double O, N gauge, whatever. We all need signals. Let's have a look what's available. Hi, welcome back to Chadwick Model Railway. I'm Charlie. Now, shooting a video on signals might well be a foolhardy undertaking. There's no doubt in my mind there are people watching this video who've forgotten more about signals than I will ever know. I offer it, from a enthusiastic amateur's point of view. I've done some research, but I'm sure many of you people will know certain aspects of it, but hopefully we can build on it together. Anyway, I am prepared for a good kicking in the comment section below, and no doubt the vultures will be circling. Anyway, let's crack on. Railways are generally split into blocks, and you have a train will enter a block from another block and go to another block, quite obviously. But the blocks are there to provide safety between trains over time and distance. So let's take a look how that works. So for illustration purposes, here's our train line and here are the blocks. And as a default setting, all the blocks these days are set to green, as in clear, so trains can run straight through them. So along comes our first train. It gets to the end of one block, and this signal refers to this block here. So it can see a green signal, so he's clear to proceed into the second block. When that happens, the green light goes out. Guess what? Yeah, you're right. The signal turns red, prohibiting any trains to come into that block because it's occupied. The train obviously then progresses to the next block, and as you'd expect, as it goes through, that signal then goes red. But back here, this signal guarding that block, which is now empty, will turn yellow. The train then progresses further, and naturally these colours will change once more. So this block becomes red, this one yellow, and this one green. And along comes another train. And it can see by the green signal that this block is naturally vacant, so it will progress into this block. It's going faster than this train, so it's starting to catch it up. But it can see now, as it leaves this block to go into the next one, that this block has a yellow light, meaning that the next signal may well be at danger. So it progresses into it, but as you'd expect, it would reduce its speed. The first train is starting to pull away once more, and as you'd expect, all the colours start to change once more. So this train now goes into this block. That block turns red. This one then turns yellow. And behind this one, it turns red. And this one turns yellow. And the sequence runs on. And I think it's pretty kind of straightforward, and all it shows you is that the automatic signalling, because of block detection on the network, will tell the system that the following block is either occupied or clear, and the block in front of that may well be occupied or clear. So you build up some safety element based on time and distance. So now turning the clock back many years to semaphore signals, how did that work? Well, block detection really didn't exist. I mean, back in the 30s, the only way that you knew there was a train coming is because someone told you, they informed you by the ringing of bells and the pushing of levers and such like. And so signal boxes were actually quite common, and they, if you look at it from a block detection side, they were closer together, so there were less blocks between them. So let's say, for example, now we've got our train over there and one here. This train might well be held there by a home signal, and these signals run in two different configurations. If the lever goes down, it's known as a lower quadrant signal, common on the Great Western and the rest of the planet, because the Great Western always had to be different, but the rest of the nation, the signal moves up, known as an upper quadrant. But these have been lent by a friend of mine, a dear friend, Ian from the Model Railway Club. You may have seen him in a previous video when we did our Chuckle Brothers sketch, but Ian has lent me just for this the aid of this video. So, but instead of keeping that one there, actually the blocks are vacant, so this train can progress on. But now it can go into this block, but not into this block, because that block there will be occupied, therefore it will have a stop sign. But here you will have a distance signal, which is the yellow, indicating that the next block is clear, indicating that the next, after the next block, it will be a stop sign. So you have the lower quadrant home signal at proceed, but the distance signal at caution, meaning the next signal may well be at stop. If that were down, then it would be because this block would also be empty, and therefore if both signals are in the down position, then you know that two blocks are empty, and I do hope that that kind of makes sense. So that's the guts of it. So now let's take a look at how we model these and what's available. So here are some of the examples that Ian has lent me, and these are made by Ratio, and they're not terribly expensive. I mean, this one was £8.85, and it builds into this home and distance signal. As you can see, this is a Great Western Region one because it has a lower quadrant movement, whereas here you can see an upper quadrant movement, and they're all pretty much the same. But to build these, it's quite a clever little system. There's wires and little levers, and you can connect cables underneath your board to go back to a small switch to operate the signals should you wish to do so. And they make a reasonable variety. And I am embarrassed to tell you that this signal here, I was actually unaware of its real purpose, because it's used at a junction, and this one here has a left-hand junction, which is why you can see this signal is lower. So if this signal was down, then the train coming along would be turning left and using the junction, and obviously if that one was up and this one was down, then it would be to go straight on. So that's the old-fashioned way of showing a left-hand feather, earmarked by the fact that they are different levels. So if you like, this is a subordinate kind of signal showing that there's a junction, and there's lots of varieties of these around. And here you can see, though it may be difficult to understand without having a vertical view of the actual track plan, but they are gorgeous looking things. And they're operated by point rodding, which comes from the front of the signal box and runs parallel to the tracks, and there is like steel bars that run out to the points and steel cables that run out to the signals. Occasionally you'll still find them in use, those surrounded by today's electrics and electronics paraphernalia here at Yeovil Pen Mill. Now I'm sure it won't come as a shock to find out that Dapol are also in the market, and they produce rather upmarket 00 scale signals, and this is one of their servo operated junction signals, very similar to the one that I've just shown you. Something a little bit more fine scale, let's say, is that behind these filters that hopefully you can see, there's an LED. So when the signal is thrown, it will go from red to green. And you can see these small little actuating arms underneath are operating the signals. Yes, but at what price, I hear you grumble? Well, this one is a meagre £64.95. I shouldn't laugh. This is a lovely piece of engineering. This is good. I like it. I do. And the single one is, I think, just under £30, about £26, between £26 and £30, wherever you choose to buy them. My thanks again for Ian for lending me his signal, and also to James at DCC Train Automation, who's given me some information and a couple of images of these. So thank you very much, James. Oh, and he obviously sells them. But there we go. Yeah, nice signals, these. And if you're into the market of upmarket electrically powered signal, then these are the ones to get. And of course, if you want it to be DCC operated, then James is your man, and he sells all the stuff to go with this to turn it into a DCC operated device. And finally, before we jump forward in time, it's worth mentioning something called ground signals. And these exquisite little models, also made up by Ian, I think they're from Ratio, control the movements based around shunting. And they're operated again via the signal box with point body and cables and that kind of thing. And they allow shunting to take place on controlled sidings. And no layout would really be without these. However, I've yet to see any that can be operated. In the stop position, the red bar is horizontal, and then when it shifts through 45 degrees, access is permitted. One of those lovely little details to add to a shunting yard. So now, just to summarise before we move on, there are 4 types of semaphore signals as far as I can figure out. There's obviously the ground signals we've just seen. There are the distance signals, and this one in particular is a fixed distance. It doesn't move because it would be in front of something like a junction where the locomotive is always warned that the next home signal is likely to be at danger. Then there is the home signals, which are these ones here, and there's also known as something as a start signal, which is more or less a home signal, but a start signal would be found something like around a station. So those are the 4 semaphore signals that were in use, unless of course you know otherwise. Now, if you're not a subscriber, don't forget there is the link there to become a subscriber, and of course it is free. And if you'd like to help support me through Patreon and become a patron, then please click the link in the Show More tabs. Right, next thing we're going to look at is light signals, and then we'll move on to gantries. So moving on to lights, and we can make this as complex or as straightforward as you choose, whether it's to do with your financial commitment, let's say, or whether it's to do with your technical ability. And this is a little 2-aspect light, i.e. it's either red or green, and it's from a company called Burco. And Burco has 2 trade names. One of them is, got to try and get this right, is Econ. And Econ, I think, is the same as Burco, but the Econ are self-assembly, whereas the Burcos then come fully assembled. And as you'd expect, there are 3 wires coming out of this signal. There's a white one, which is the common, and a red one and a green one. It's not rocket science, is it really? And with my trusty old duet transformer, so if I put 12 volts DC onto there, hopefully you see the green, and if I put it onto the red cable, it's not going to be any great surprise, is it? Because there's the red, all straightforward. So 12 volts DC, and the LEDs are protected by a small resistor that's kept in the circuit, and that is supplied by the company when you buy the signal. So all you need is a little 2-position switch with a common terminal in the middle for your common wire, and then, as I said, a one position for green and then the other position for red. So it would always be on in one position or the other. So of course we can make things as complex or as straightforward as we wish, and this being a 4-aspect signal, we have a red single yellow, double yellow and a green. So obviously we need a 4-position switch. All straightforward and all basic wiring. Again, from Burco. So moving on from basic signal operation, where do we go from there? Well, without getting too complicated, you can go to automatic signalling on a timer. And this little beastie here is an ASP1 from Block Signalling. And if I open this little packet, what we have inside is a circuit board, and here on the top is this little infrared sensor, and it sends out an infrared beam, and then when a locomotive passes over the top it bounces back into the sensor, and then through this circuit board it changes the signal from green to red, and then over time, that's preset into this, you can adjust this yourself. Over time it then goes to yellow, perhaps to double yellow, and then back to green. So there's no other input whatsoever bar just installing it, setting it up, setting the correct sequence timings, and then leave it alone. At the Model Railway Club I'm associated with, West Camel Model Railway Society, we have one of these just inside a tunnel entrance. So the sensor needs to be mounted up between the sleepers, and then the board mounted sort of underneath it, and it's just a case of putting it in position and then just leaving it alone, and it's away. From block signalling though, things can get more complicated if you want them, and you can run a section of interlinked circuit boards to sort of get your signals then to run in a synchronized and more realistic manner. So it's an avenue to go down. But the next thing to look at is DCC operated signals. Now this is a dual home signal, that is 2 red and green signals. Sort of thing you'd have perhaps in a station where you've got 2 lines coming out. And it's made by Traintech, and the price is round about £34. That's it from Traintech, a decent company. They're not going to like it. It's a better quality item than Burco. There we go. And as you can see, there are these 2 prongs, and these 2 prongs are supposed to fit into Bachmann or Hornby track. But it says in the instructions, simply cut them off and you solder your DCC feeds into these 2 small contacts. Easy. And instead of doing that for this operation, what I'm going to do is just get my good old trusty Bachmann Dynamis, and then hopefully those lights will come on, and show you how they work. I don't use the Dynamis I use very much for the in front of camera stuff. The main layout is a Digitrack system. So with this, hopefully I can get those signals to change. You have to program them with an accessory address, not a locomotive address. It must be an accessory address. Accessory number 60, and I throw and close. Simple as that, throw and close. And the other one is on 70, and once more, throw and close. Throw, close. Well, that's all straightforward, but what if you want something a little more complicated? I mean, this is ideal to put at the end in the centre tracks of a pair of platforms controlling 2 trains coming out of a station. But what if you want things like feathers? Where do we go from there? Well, to give you an example, this is a shot of Castle Carey station, and the lines coming out going towards Paddington. And as you can see, there are 3 tracks. The left-hand track is the up line towards Paddington, the middle one is the down track from Paddington, and the far right hand is a feeder line for the DMUs coming across. And as you can see, there is the facility for the DMU to cross both tracks onto the main up line, and also a train that's on the down line can cross and go across to the up line when the signals permit it and the feathers are lit. So let's have a little look at feathers. So here is Train Tech's model of a 3-aspect signal with a right hand feather. And what I'd hoped to use this signal for was holding a loco back at the end of the viaduct before it comes across and then into the industrial unit or straight on into the tunnel. So if it were to come into the tunnel, the feather would not light and it would just get a green light and go straight across, whereas if it were to take the industrial unit, then the feather would be lit with an amber. So what happens now? Well, first thing we want is a yellow signal with a feather. So hopefully if I press 81 and then follow it with 82, the feather will come on. And there we are, clear to go across. So once the loco has gone across, we just want to go to the red light on its own. Should a loco wish to go straight across into the tunnel, then we can either give it a green or a yellow. There's a couple of other things worth mentioning at this point, and that is full computer control. And to that end, I use Digitrax and I use an SE8C. And here you can see me programming it in a previous video, and there should be a link up here on how to do that. It was a bit of a challenge, but the manuals aren't ideal, but I got there in the end. And also, if you're into DigiKeys, their equivalent of an SE8C obviously exists, and you might be using iTrains and all that kind of stuff. And I mention that because if you choose not to use the Train Tech signals with the decoders, then you can use the ones without the decoders into things like the SE8C or the DigiKeys equivalent, if that makes sense. There's 2 other companies worth talking about. No, that's unfair. There's 2 other companies I'd like to talk about, and I'm sure there's loads more. And that is CR Signals, and I believe it's a gentleman who makes signals to order, and they are very good quality. And also Absolute Aspects. And these 2 companies are pretty much at the pinnacle of model railway signals, or so I'm led to believe. I've had no problems with either, and I've seen examples of both. There we go. CR Signals, it's all handmade brass, so it is top quality, and you may well see that it's out of stock, but if you order one, apparently he'll make you one. And with Absolute Aspects, his signals are made of white metal, and there's also certain parts that are 3D printed, but again they are from the very, not top shelf, top drawer, top shelf. They are from the top drawer. 2 companies, great quality, check them out. I actually need to buy one with the two feathers at the sort of 2 o'clock and the 4 o'clock position, where my layout runs into the station and off to the branch line. So I'll have to save up a few pounds and buy myself one of those. So I'll see what's available from both those companies at the time. Now let's get back to Gantrys. Gantrys, well, I appear to own 4. There is this little beauty. I think it's an original Airfix kit. It may be produced by Dapol now. It's kind of train setty, cheap, cheerful, is what it is. But with a little bit of TLC, you could do some bit of cutting around here and make it look reasonably passable. Not bad little kit, really. Then there's the one from Ratio, which I do like. And it's the number 478 Pratt Truss Gantry. Comes as a little kit, a little bit of white plastic, and if you put it together, it tends to come out looking like this. It is flimsy. I mean, I can't deny that. There's not a huge amount to this, but with a little bit of TLC, a little bit of tweaking, then you could end up with something a little more passable, like this one here. And this is one I made out of 2 kits for our little model railway club, and here you can see it in situ with 3 2-aspect lights, and it sits there quite well. I've removed it recently because we were ripping up a certain section and I didn't want to get it broken. However, I managed to break it myself when I took it out by dismembering the cables. Plonker. And also my fourth one is made by Traintronics, and it's a brass kit, and it is quite vulnerable. If you kind of crunch it, you're going to bend it and you can't really bend it back. Because of its vulnerability, I put it away in a box to keep it safe. I haven't got the faintest idea where it is. Absolutely no idea. I've hunted the place down for the last half hour. Can't find it. But in all honesty, that brass kit, whilst it's nice to put together and I see them at exhibitions, there's no rivet detail or anything on it. And this is a better kit. And it comes together quite well. And of course, there are decent bridges, decent gantry still around, such as the one in Scarborough. And it does look very nice. So yeah, gantries, they are what they are really. There's not a great deal out there. So, you know, you kind of pay your money, take your chance really. But that's the one that gets my choice. It's just a couple of quid and not the brass one that you would spend absolutely hours building. I made it out of brass and solder. Some people use super glue, but at the end of the day, once I built it, it was just too smooth. There was no detail on it. Whereas this one here has loads of detail really. You know, it's not bad. A little bit of box section inside to hide the cables, and it's come together quite well. So there we go. Gantries. Not a lot to say. There's not a lot of them around really, not a lot of choice. Always scratch build one, couldn't you? Well, I hope you've enjoyed that today, and rest assured everything you've seen today I have paid for. There's no donations from anybody, except of course the loan of the signals from my friend Ian. He was a good star for lending me those, and thanks to James at DCC Train Automations for his advice. So that wraps it up. Don't forget, if you like the video, then give me a thumbs up, and you can always give it a share. And if you would like to help me, then please become a patron, and don't forget to subscribe. In the meantime, there's a video here and here. I'll see you Friday, 12 o'clock. Don't be late.